So you want to impress your team with AI talk, but you're not a machine learning engineer, you're a software developer who still copy-pastes Docker files from Stack Overflow. Good news, you don't need to become a machine learning engineer, just learn how to flex like one. But first, what is a LLM? A large language model is basically a glorified autocomplete trained on half the internet, including code, Reddit arguments, and Stack Overflow copy-paste. It doesn't understand anything, it just guesses the next token based on statistical patterns, kind of like your team lead during sprint planning. It's trained using billions of parameters, a ton of GPUs, and one intern constantly monitoring for hallucinations. Here are 5 key concepts you can drop in conversations that make you sound like a machine learning wizard. Tokenization. LLMs don't see words the way we do. They break them into tokens. A token is a chunk of text, sometimes a word, sometimes syllable, sometimes just a single character, or something even weirder depending on the tokenizer. Why it matters? Token count limits how much you can shove into the model. Say, yeah, this prompt's too long, gotta trim it to fit within the context window, and boom, you now sound smarter than 80% of LinkedIn AI influencers. Attention mechanism. This is the core idea behind transformers. The model architecture powering ChatGPT, Claude, Llama, and your neighborhood AI startup that's disrupting compliance. The model doesn't read text in a linear way. Instead, attention tells which words in a sentence are important in relation to each other. For example, in the sentence, the cat sat on the mat and it looked tired. Attention helps the model understand that it refers to the cat and not the mat, unless it's a very tired mat. Say this in a meeting. Well, the self-attention weights prioritize context dynamically. And just like that, no one will ask you any follow-ups. Embeddings. An embedding is a way to convert text into numbers, specifically dense vectors, so machines can do mathy things with it. It's like giving the machine a gut feeling for how similar two things are. Cat and kitten will be close in a vector space. Java and Spring Boot might be near each other, and Java and job security might be in another galaxy. Embeddings are how models remember, retrieve, and rank information in RAG and search systems. Say, I just generated domain-specific embeddings for our API docs. Then go back to watching YouTube. Fine-tuning. Fine-tuning is the act of retraining a base model on your own data so it becomes a little less general and a little more like your annoying team lead who always quotes RFC specs. There are 3 different levels. Full fine-tuning, expensive, slow, GPU melting. LoRa or QLoRa, efficient fine-tuning by adding lightweight adapter layers. You can do this on consumer GPUs, Raspberry Pis, or toasters. Use this phrase: we are running a LoRa fine-tune on top of Mistral with project-specific prompts. Then hit Alt+Tab to hide the fact you're still editing YAML files. Inference. Inference is just the forward pass, the part where the model takes a prompt and spits out a response. It's like hitting enter on ChatGPT, but with more latency and a lot more cloud billing. The heavy lifting already happened during training. Inference is just the act of running the trained model to generate results, whether that's code, text, or horoscopes. Now that you know how LLMs work, let's see how to pretend you're doing something important. Set up a local LLM with a llama, give it some of your project's code, and run inference on your own terminal. Boom, you're now the AI guy at work. Mention RAG, retrieval augmented generation, a fancy way to say Google then paraphrase. Use it to build your own AI assistant, or just flex about it on Twitter. You get bonus points if you use the word embedding in casual conversation and refuse to explain it. Congrats, you're now an AI bro. But how to actually use this stuff as a dev? You don't need to build a model. You need to use it. Auto-generate documentation, write tests from code, answer questions about your codebase, build chatbots that don't suck. These models are just fancy pattern recognizers. And guess what? So are developers. And here's the stuff you don't need to actually understand. Backpropagation, gradient descent, tensor shapes, the actual math in the attention is all you need paper. Just nod when someone mentions PyTorch and respond with, yeah, I prefer the Hugging Face implementation for that. That's it. You can now bench 40 billion parameters and you'll know exactly how AI works when it will take your job. In 2025, machine learning engineers are the new rock stars, but most of them are just doing data plumbing in a Google Colab. You're smart. You're going to flex just enough to look dangerous, but practical enough to build things that work. Remember, it's about saying transformers in a meeting and letting everyone assume you're a genius.